Guys, welcome back. Today we will again have some very good problems from Alan All India test series for JEE Advanced. And as I promised, I would also choose what I'm doing is I will choose, I guess, one or two random JEE Advanced PYQs also at the end of this after we solve these questions and then do them also. And I don't know if you guys have if you want me to bring PYQs separately in some other video, maybe chapter wise, or if you want I could bring them randomly also. Please tell me this, okay? If you want, I was thinking of doing a PYQ series, but because you are demanding these questions, so I'm bringing them. But if you want PYQs also, you can write out to me in the comment section if you want me to make a separate video on PYQs maybe, or if you like this procedure that I can do some PYQs at the end of each such session, like one today, so then I will do that only and continue. So let's start off with today's video. So this is the first question for today. I would like you guys to try it out once for yourself, and then you can pause the video and try it out. I will wait for a few seconds. Okay, so let's start off with this question. So basically nothing in the question much given. We have to solve each of these options. And as you can see, actually option A is one option, option B, C are option A is one option, meaning option A is actually one question, B, C are one question, and D is one question. So basically three questions. I hope you can understand. So let's do it part by part. So first, let's get on to option number A, where we have to find the value of this big trigonometric expression with a sigma. So anyways, because minimum value is there, so let's not mingle with trigonometry and quickly remove these sine A, sine B, sine C, whatever stuff. So first I will write the question. This is sigma root under sine A and whole divided by root under sine B plus root sine C minus root sine A. Now what we will do is I want to get rid of these sine and stuff. So we will quickly make a substitution. Let small a be k sine A. Let's say let small b be your k sine B. This is B, okay? This is your B. And C is your k sine C. And this was capital B, I'm sorry. So yeah, now if we substitute like sine A as A by K, sine B as B by K, sine C as C by K, so we will have root K's all over and they will get cancelled with the numerator and denominator. So basically what we will be left off over is with this thing, sigma root A by, this is your root B plus root C minus root A. So now I guess this denominator could give us something. So let's take this to be some quantity. Say we take root B plus root C minus root A to be X. Okay. So now I guess one thing which you guys can understand is that when we will actually solve for this sigma, when we take this when we open up this whole thing from the sigma, what we will actually have is root A by root B plus root C minus root A. This will be the first term. In the next term there will be root B in place of root A. These two will become root C and root A, and this again will become minus of root B, and so on. We will actually have three terms. Okay, so basically what I am doing is I am writing the denominators of all these three terms, so which is easy to determine. This is root C plus root A minus root B, one will be one of those. So let this be, say, y. Let this thing be your root A plus root B minus root C. Let this be z. So now what I will do is I will add up these three. So you can see root A, I guess one root A, root B, root C will be remaining. So this thing is your equal to x plus y plus z. So now I guess we can manipulate this sigma to something. Okay, I will tell you guys how. So basically now my motive is to convert this thing in terms of x, y and z. So let's try to bring out the numerator first from these equations. Okay, so if you guys are good at looking into these equations, maybe you can describe it somehow like that. So you will see that on adding these two equations, like these two, We'll actually get root b minus root b cancelled, root c minus root c cancelled, and from here we will get root a as y plus z by 2. And once again, this thing is your x, so this thing becomes sigma y plus z by 2 times x. Now let's take half outside, so this becomes sigma y plus z by x. Now I guess we can open up the sigma, and if you write this thing as, say, you can write this elaborately as y by x plus z by x, something like this. Okay, and now if you open up the sigma and write this, you will generally get all such terms, which means you will get y by x plus z by x, and after that say x by y and z by y, after that y by z and x by z. I guess no more terms. Like we will obviously exclude those y by y, z by z, x by z are not included here. Okay, I hope that is understandable. So now we can write this thing like, as we have to find minimum value, I guess, so because we can see y by x and x by y are present, so sort of like this step becomes really tasty, you can say, to apply AP, I'm sorry, not AP, AM greater than equal to GM. Like ready, we just have to arrange it in pairs. Okay, so we can arrange it like this: y by x plus x by y. Then we can write off z by x plus x by z. Then we can write off y by z plus z by y, and so on. And now what we can do is we can write this as half multiplied by, now what I am doing is basically I'm not calculating this, or I will show with 1, although there is no point in showing. This thing is by 2 greater than equal to root under this thing, which gets okay, not x by y, I'm sorry, it's x by y, and root under multiplied these two, so greater than equal to 1. So basically all of these will be greater than equal to 2. So I'm writing this something like this. Okay, just like skipping the steps. This is a pretty obvious thing. So this thing will actually be greater than equal to half into 6. That is, this thing will be greater than equal to 3, which was our option A. So your option option A is basically correct. This was option A. So now I will move on to option B and C, and let's see what we can find. And if you guys also look into option B and C properly, we have to solve option B and C for 30 and 30. Basically the same thing, and we have to see which of these is correct. Okay, so let's move on to that. So now let's talk about option B and C. So in option B and C, basically we had two terms, okay, or we can say two expressions in trigonometry. I will write them down quickly. Yes, so our two expressions were secant A secant B plus of tan A tan B, and I guess one expression was secant A tan B plus your tan A secant B. I guess this was given and this we have to find, right? So what we can do is, like, we have to obtain something, a relationship between these two expressions, so that we can actually get our desired result. Now if you like observe carefully, we will try to manipulate this a bit. So let's like break this in terms of sine and cos. So this thing becomes 1 by cos A cos B, and I'm not writing much. This will be sine A sine B by cos A cos B, so 1 plus sine A sine B by cos A cos B, and this thing is your, I guess, sine A by cos A cos B plus sine B by cos A cos B and sine A by cos A cos B. So sine A plus sine B by cos A cos B. So basically now we have two expressions ready. Now what I will do is, the next step I am going to do is nothing of sort of thinking. This is like prior sort of observation I did after watching these two expressions. Okay, like you can do some sort of trigonometric manipulation, but I guess this thing should come into your mind when you see this. At least it came to my mind, so I expect that from you also. Basically our secant A secant B term was this thing. Okay, so if I take this Like if we take this expression's whole square and subtract from it this expression's whole square, you will see the denominators are already same. Okay, so if we actually subtract these two, this will actually come out to be 1. You can manipulate and check out. Like 1 plus 2 sine A sine B plus sine square A sine square B minus sine square A minus sine square B minus 2 sine A sine B. So minus and plus 2 sine A sine B, they get cancelled, and you will have 1 minus sine square A plus 1 minus sine square B. Okay, I guess something like that. Yeah. No, I guess it was 1 plus sine square A sine square B minus sine square A minus sine square B. So after that, if you, yeah, so in that particular step, if you take common, basically you will have 1 minus sine squared A multiplied by 1 minus sine squared B. That is cos square A, cos square B. In the numerator and the denominator also you have the same thing. So both of them get cancelled and you get 1. This was pretty simple, I guess. I manipulated this thing live just in front of you, okay? I didn't even see anything and did all of this mentally. So I expect that from you also. So yeah, that is the key to solving this question. And now let's take a look at what sort of values were given. So our this thing was given out to be 30 and we have to find something. Okay. So let's do one thing, not complicate things, because our this thing was, let's take this first equation as 1 and this as 2 and then solve it. So it's basically 1 square minus 2 square equal to 1. Now our 2 square is 900, right? 900. So this becomes 901. So I is your root under 901. I mean 1, not I. 1 is your root under 901, or if I say secant A secant B plus of your tan A tan B is equal to root under 901. For which I guess option B was correct. Option C was root 899. So basically, which means this part is important. Okay. You do a small mistake, subtract this maybe from this, your question is gone. Because they have root 899 also available, root 901 also available. You could, like, there is a huge probability that people will make mistakes here and take root 899 as answer, and so their like 5 marks is gone from the paper. Anyways, so this was this question. This was not very difficult actually, but yeah, you have to keep your eyes open. So now let's move on to option number D, where we have to find, I guess, an orthocenter. So let's move on to our final question. I mean, final option. So in the final option, I will first write down the lines which were given. These are y minus z minus 1 equal to 0 equal to x, and z plus x plus 1 equal to 0 equal to y, and I guess x minus z minus 1 equal to 0 equals to, I guess, z. These are the 3 lines. Okay guys, this is not z, this is y. I'm sorry. So now what we will do is we have to find out the points U, and this was R. This I forgot the name, I will check once. Okay, this was M. So now clear cut they have given that these points all lie on the xy plane. So basically everywhere z becomes 0. So I'm not going into the calculation, this is pretty simple. So this thing U will come out to be your 0 1 0. M will come out to be your minus 1 0 0. And R will come out to be your 1 0 0. So basically what you can do is you can actually ignore the z point and solve this in 2D itself, because even in the answer these three are 0 because it's in xy plane. So basically orthocenter is also in xy plane. So if you neglect this also during your calculation, there will be no effect on the answer. So basically we can calculate this whole thing in 2D plane. So basically you have a triangle which is our triangle U01. Okay, I will plot this, just a minute. Let's plot this thing. This is your 0 1, this is your minus 1 0, and this is your 1 0. So it's an equilateral triangle. Wow, I didn't notice this. This thing is your equilateral triangle. Yeah. So I guess we have to find the orthocenter for this triangle, which is I guess like very simple. There will be no difficulty at all. So orthocenter will be same as the centroid because it's an equilateral triangle, right? Okay, just a minute, just a minute. Okay, guys, I'm sorry, it's not an equilateral triangle. I just got confused because these points were same. This is not an equilateral triangle actually, it's an isosceles triangle. So yeah, if you have to calculate the orthocenter, I guess we have to do it using our straight lines method. So I will not go into the calculation for this because we have a lot of questions ahead. So basically our orthocenter will actually come out to be 0, 1, 0. Like this option is will be correct, right? Option D will be correct. And I will tell you the process also. What you can do is you can join, like we have the line segment UM with us, and say you take the orthocenter somewhere here. Although it's lying on the y-axis itself, okay. This is actually becoming the orthocenter. I don't know how, but yeah, calculation is giving this as the orthocenter. So anyways, you can calculate this thing and option D will come out to be correct. I hope you guys know how to calculate an orthocenter, right? I'm not going into that because this is too simple. So basically our correct options for this question will be A, B and D. Okay. Yeah. And guys, if you have like, I don't think you will have any problem calculating this, but still if you have, as I always say, you can write down to me in the comment section. I will make a post about that and you will have clarifications ready. So yeah, you can always ask me like any doubts you have throughout the video, please ask me out in the comment section. Don't hesitate. I will surely reply. So that's it for this question, guys. Now we will move on to the second question for today. So here's our second question for the day. This is a good question, like very PYQ based and not exactly PYQ based, but yeah, questions like this are have been asked sometimes in JEE Advanced. So let's do this, and you will find this question in good books also. So you can try this question out. Very good question. I will wait for a few seconds. Okay, so I'm starting off now. So basically some information has been given that we have a function y equals to f of x, which is differentiable and hence obviously continuous, and it is passing through m1 comma minus 1. So we can write that f of 1 is your minus 1. And it has a property that the chord joining any 2 points x1 comma f of x1 and x2 comma f of x2 always intersects the y-axis at n 0 comma 2x1 x2. So what we'll do is let's first write out the equation for this straight line AB, which is I guess very simple. We can write this equation as, say we take the point of reference to be f of x1 comma f of x1. So this thing will become y minus f of x1 equals to f of x2 minus of f of x1 divided by x2 minus x1 times x minus x1. That's it. So now I guess we have the equation ready. So as this always intersects the y-axis at n 0 comma 2 x1 x2. So in other words, this point will satisfy this. So let's put that. We will basically have with us minus 2 x1 x2 equals f of x2 minus f of x1 by x2 minus x1 is your 0. Okay, and we can also put f of x1 as 2x1 x2 here also. And our x minus x1 where x is 0 and this is your minus x1, so minus and minus are cancelled. So basically now I guess x1 and x1 will also get cancelled. Okay, just a minute. Okay guys, I did a little bit of calculation mistake here. I will rewrite this again, okay? So please bear with me. This thing is your 2x1 x2 minus f of x1 equals f of x2 minus of f of x1 by x2 minus x1 times minus of x1. And now I guess if we put, I can rearrange this to somewhat this form, like minus x1 by x2 minus x1 equals 2x1 x2 minus f of x1 by f of x2 minus f of x1. This step is not a mandatory step. I just did this because in this step it was becoming clumsy and I was making mistakes. Although if you can directly substitute in this step, there is no problem. I just did this for some clarity. Okay. So now if we put on the point, which is our f of 1 equal to minus 1, basically we put 1 comma minus 1 on this. Okay. Not on this, that would be wrong. I would say that f of 1 equal to minus 1. So we are basically substituting x1 as 1. So that thing becomes minus 1 by x2 minus 1 equals to 2x2 plus 1 whole divided by f of x2 plus 1. And now if we cross multiply this, this will become minus f of x2. Okay, after this we have here, okay, after this step. So minus f of x2 minus 1 is equal to 2x2 square minus 2x2 plus x2 minus 1. So our minus 1 get cancelled, 1x2 will be reduced, and if we shift to the minus to that side, we will have our f of x2, or rather our function ready. So I will change the page quickly and write. So our final function for this question which we have to find, it will become f of x2. The whole expression will come in x2, so I am writing f of x equals to x minus 2x square. Basically this is the function that we have to work with. Now I guess in the first two questions we had integral 0 to half f of x to be found. So let's quickly find that. This will be integral 0 to half x minus 2x squared dx. So x square by 2 minus 2x cube by 3 from 0 to half. So these are both zeros, and this thing will I guess become minus 1 by 8 and minus 1 by 8 plus, okay, not, yeah, minus 1 by 8 plus 1 by 8, and that is cut by 2. So minus 1 by 8 plus 1 by 12. I guess this will come out to be 1 by 24. Yeah, this is 1 by 24. So basically I guess this question, I will check the options later. Like, this is our result we obtained for the first two options. I'm seeing which option was correct. And now I guess we have to find something else also. I will look at it once. So basically from here we had to also find the area which was bound by f of x and the x-axis. So we have to find out critical points. So let's do that. I will take this and say if we write this as x into 1 minus 2x and put that equal to 0. So I guess x equal to 0 is 1. Okay, and I will quickly write out the expression for this. Just a minute. I will change the page. So we had to find the area which was bound by this curve and the x-axis. Now there will be a slight confusion here. I guess there is something like wrong in the language of the question. Like in options C and D, they have given something of the sort that we have to calculate the area of this curve and between the x-axis. But my question is that the curve goes something like this, right? If you draw the curve, this goes something like this. And this is your required area, right? 0 to half. So it should come out to be 1 by 24 only, but it's not matching. And that is the problem. So basically what we will do is, I guess the question had to be something of the sort, I will tell you. The question had to be something of the sort like, if say the graph goes like this, the question could be that we have to find out the area that is bounded by f of x and the area that is below the x-axis, such that at the point where this particular curve actually intersects a point where the abscissa is an integer, something of that sort. Because guys, when I checked out options C and D, none of them were equal to 1 by 24. That was the first thing. Now because this side there is like, it is going down to hell infinity. So basically we had to calculate like this part, right? 0 to half. So I was looking at this side, the positive x-axis. Now I don't know what they meant using this, but if you see the answers, you can match the answers only when you take this area. and this is your 2. Basically what I mean is only when you put x equal to 2, it is the closest, or rather the point with the smallest abscissa where this x coordinate is an integer. If you start off from half, at no points, like if you see the vertical lines, right, if you one maybe somewhere here, it is not intersecting at any point which is in, like when we put x equal to 1, f of x, I guess 1 comma something is not coming as an integer. Like that is my doubt, what sort of thing they have meant. Anyways, we have to abide by whatever is given in the options. So basically I guess this should have been the area, right, because the curve is intersecting x-axis above, and 0 to half should have been the area. But if you see the options once, I will show you the options. If you see the options, they are 10 by 3 and 8 by 3, which is never, like not at all equal to half. And you can see the question also, area bounded by f of x and x-axis, like y equal to 0. So now if we like see our graph, this should have been the area. I don't know what they have meant, but actually you can say that I just randomly put this thing because I can't find any meaning, right? If you put a as integral 0 to 2 x minus 2x square whole dx, this was the nearest I could get. This actually, if you evaluate, this thing is actually coming out to be 10 by 3. That is matching with an option. But if you had this thing, then you could have either given limits, or if you want us to calculate the area, then why not give this area rather? Then what is the point in giving this integral, and after that what is the point in giving this? I couldn't understand the language of the question. But yeah, to solve, this is basically what we had to do. We have to find out this area, and that is why, because it is below the x-axis, I put a modulus also. That's it, and I guess I will check on the correct options once. So our correct options for this question were B and C. I don't know whether this question is correct or not. I solved this thing like that, but like language wise, the question is not pretty depictable. I can't differentiate between this options A and B and option C and D. Anyways, and if you guys are not satisfied with this question, I am also not satisfied, so why should I say? But anyways, I will try this question once more out, and I will also try to look out for the official solutions, if any, for this question. I don't know if there is available. I will try to look out, but let's keep it to this, and the answers, let they be B and C for the time being. And if I get anything like updates for whether this question was correct or not, I will surely inform in the post section, so you can watch out. Anyways, we will move on to the next question now. So here's our next question for the day. This is a very simple question, and just one small step that you have to see, and the question will be done automatically. So I will wait for a few seconds. You can try this out. Okay, I am doing the question now. So basically we have something of this sort, a plus 2c by b plus 3d, and I'm taking this plus 4 by 3 to the right hand side. So this is your minus 4 by 3. So basically minus 3a minus 6c is your 4b plus 12d. Now if we take these two terms to the right hand side again and fully take this complete thing and the positive sign, this is your 3a plus 4b plus 6c plus 12d equals, I guess, 0. This is what we have. And now I will make a quick observation in this particular part. Now if you guys actually observe this equation, ax cube plus bx square plus cx plus d, basically what you can make out from the question is, in our 4 options we have been asked about roots, right? And we have at least one root in -1 to 0, at least one root in -1 to 1, and options like that. So basically, like any guy who has learnt application of derivatives very properly, or maybe even theory of equations, you can easily ascertain that this question has something to do with Rolle's theorem, right? Either Rolle's theorem or intermediate value theorem, we will see it. So what I will do is, I'm trying to relate this equation somewhat to this. So we have a, b, c and d in the equation, like quadratic equation itself. And now one thing which I can observe is, if we try to, like, say if we try to integrate this thing from 0 to 1, okay, right hand side will still become 0. This is becoming your 3ax cube by 4 plus 2bx cube by 3. Okay, and that was enough for me, like 3 by 4 here in the first term and 1 by 3 in the second term. And d, when we put the limits, it will come out to be a single d. But here we will have in the limits 4 into 3, 12, and here also there is 12. So basically this thing, like this particular thing, integral form is actually equal to this. Okay. So basically they had given us this particular thing to get this thing with back calculation, some sort of. So yeah, and now what I will do is, let's take this thing as f of x, not the integral part. Okay, I have written integral 0 to 1 f of x dx to be 0, and I also forgot to put a dx here. So now let's take this thing to be a g of x, although now I guess the question is pretty obvious and straightforward, but still I am showing. So we can write from here that g dash x is equals to f of x. Now 0 to 1, when we are integrating, the area was 0, which basically means that at 0 to 1 there is no area enclosed by your f of x, which also means that the roots are somewhere in between these two. Otherwise there would be some area of, like, if you take any roots to be outside 0 and 1, then also there would be some area enclosed in between 0 and 1. But because the area enclosed between 0 and 1 is 0, basically there should be some roots in between these, right? Now what are the number of roots, we don't know. So yeah, there will be at least one root in between -1 to 0. This is pretty obvious. And now I can say one more thing, like if there is at least one root in between not -1 and 0, just a minute. This is not -1 and 0. What did I write? This is 0 and 1. Yeah. 0 and 1. Between that, we will have at least one root. Now, if we look at this thing carefully, g dash x is your f of x. So now from Rawls' theorem, we can say that if there is one root in between 0 to 1, there has to be one root also in between -1 to 0. I mean, -1 to 1. I hope you guys can understand, like -1, 0 and 1. So if there was a root here, and g dash x is your f of x, so if f of x has a integral f of x is 0 between 0 to 1, so if there is a root here, then by symmetry a root should be here also, because area enclosed between 0 and 1 is 0, right? So now, like, not only one root, there can be many roots, I don't know, but yeah, at least one root in between -1 to 1, and that was later, and first we concluded 0 to 1. So basically options B and C are correct, I guess. In this question, options B and C will be correct. -1 to 0 is not correct, because we can't ascertain whether, like, from 0 to 1 we went to this conclusion, but we can't directly go to -1 to 0 from anyway. And no root in -1 to 1 will also be, I guess, not fully correct, because we have ascertained that between 0 to 1 there can be one root. Okay, so now you never know where that root lies. So basically, and anyways, no root in -1 to 1 will obviously be false, because there is at least one root between -1 to 0, at least one root between 0 to 1. So obviously there has to be at least two roots in between -1 to 1. So option D is also wrong. So B and C are the correct options for this one. This was simple application for Rawls theorem, but yeah, this part, little bit of observation is required. Anyways, now we will move on to the, like, the really great questions in this session, the comprehension type questions, which are actually the special ones that I've brought for this video. Let's go on to them. So here's our comprehension type question, and this question was a really good question. I like this question. So, like, no, it's not like pretty, I would say, difficult, but yeah, the manipulation that is used here is essentially very, very good. So you guys can try out this question if you want. I will wait for a few seconds. You can pause the video and try out. Okay, so I'm starting off now. Basically, we have to find out fx and gx first before proceeding. So let's find out. Fx is given as our limit n tends to infinity, cosine root under x by n, and this is also whole powered n. So basically you can observe this is your 1 power infinity because cos 0 is 1 and 1 power infinity. So we can make this e power limit n tends to infinity cos root x by n minus 1 and the whole multiplied by n. Now if we take the minus outside, and this will become 1 minus cos root x by n, which we can write in terms of 2 sine square theta by 2, right? Because 1 minus cos 2 theta or 1 minus cos theta is 2 sine square theta by 2. So this thing will become, after taking out the minus here, this thing will become minus, okay, minus is there, and this is 2 sine square, and we can also put an extra bracket, half root, like this is basically theta by 2, so I wrote it as half root x by n and whole multiplied by n. Now I guess this is pretty simple because the argument of sine is tending to 0. So you can immediately replace this thing with squared. We can write this thing like this: e power minus limit n tends to infinity, and immediately we can replace this as I have done. So 2 into 1 by 4 into x by n into n. So now after all the cancellations, we finally get our f of x to be e power minus x by 2. This was for f of x. Now let's find out g of x. So for g of x, I guess g of x was given to be, I will just see the expression once. So this was the expression for g of x. So basically what we can do is, we can, again, this is your 1 power infinity, you can observe. So we can write this as e power limit n tends to infinity, and now when we do the minus 1, this plus 1 will get cancelled. So minus x plus x into e power 1 by n. So we can take out x outside, and we will take it outside the limit also because x has nothing to do with the limit. So here comes x, and we have here your e power 1 by n minus 1 by e power 1 by n. Sorry, not e power, only 1 by n, because we wrote this thing like it came down as n, like this thing minus 1 multiplied by n. So we wrote it in the denominator as 1 by n. Basically you can understand why, because this thing becomes e power x minus 1 by x limit, where x is tending to 0 because x equal to 1 by n here. Like, I guess I said the variables, you could, don't mess up, okay? I said x like an example, don't like think that I took, why did I take x here and all. And I will write this anyways, otherwise you guys will mess it up. Like this is pretty simple anyways, but still I will write. This is limit y tends to 0, where I put y as 1 by n. So this thing becomes e power y minus 1 by y. And this thing tends to 1. So your g of x is e power x. Please don't confuse. Yeah, now I guess things are ready. So we had to, I guess, find out tan of g inverse of f inverse x. Okay. So for that thing, if we have to ascertain, we need to first ascertain both g inverse as well as f inverse x. So g inverse x is pretty easy to ascertain. It is your nothing but ln x. And we also need to ascertain f inverse x. So first I will take y as e power minus x by 2. And as you all know, to ascertain any inverse function, we have to change x and y like this. Now you can take ln on both sides, and then after we manipulate, f inverse x will come out to be 2 ln of 1 by x. Basically minus 2 ln x, I wrote it as 2 ln of 1 by x. So now your g inverse of f inverse x, this thing, it will come out to be ln of like ln of 2 ln 1 by x. I am writing it as ln of ln 1 by x square. So our final expression is, I will write it down, our final expression. So our h of x is your tan inverse ln of ln 1 by x square. So now let's do one thing. Let's at first simplify the first question which was given here. So basically the first part said we had to calculate this thing. modulus limit x tending to 0 plus. I guess this was given to be your ln of f of x divided by ln of g of x. So if we calculate this particular thing, this will, I guess, come out to be your minus x by 2, and this thing is your x. And you can include, I forgot to write the limit here, but anyways x is getting cancelled. So your answer for the first part, I guess, okay, there was a 4 also here. So 4 into half, your answer for the first part comes out to be 2. Now we move on to the second part where we have to find the range of the function h of x, which is your tan inverse of ln 1 by x square. So let's do this thing quickly. So basically now what we will do is I'm leaving tan inverse for a while. Let's first analyze this inner function. So in this inner function, if we tend x to 0 plus, you will see that our ln x is basically tending to minus infinity. Now you will ask me why, because ln of 1 by x square, and if you observe the graph of ln, the graph is something like this, right? So basically x when tending to 0 plus, ln x is tending to minus infinity. So if we take minus 2 ln x, which is our basically ln of 1 by x square, it will tend to plus infinity. I just wrote this. So now if we take ln of minus 2 ln x, that is our thing, this thing, so it will tend to minus infinity once again. I mean, sorry, not a minus infinity, plus infinity, yeah. So this is it, and we have to also do for x tends to 0 minus, so I will change the page. So now if we tend this thing to x tends to say, no, we are not taking 0 minus for a reason, okay, because basically otherwise this thing will not satisfy. You have to also remember that the domain of x here will be only in between 0 to 1 because it's a ln function, right? So we can't basically take 0 minus, we have to take 1 minus. If this thing is not satisfied, then finding out the range of this is actually illogical. So you have to take care of that, okay? I hope you can understand. So now if we tend x to 1 minus, ln x, as you can observe from the graph, will tend to 0 minus. So our minus 2 ln x will tend to 0 plus, and simultaneously our ln of minus 2 ln x will tend to minus infinity. So basically, for the domain of this inner function, it's actually covering the entire number line from plus, like from minus infinity to plus infinity. It is covering the entire number line. Okay, we can write out range of ln 1 by x square. This thing is actually your minus infinity to infinity, or you can say all real numbers. So basically now all real is not our cup of tea here, because we have to also put tan inverse. So if we put tan inverse with this, basically h of x will have a range minus pi by 2 to pi by 2. That's the range for this particular function, and the range was given out to be a comma b, and we have to find out a plus b. So a plus b is 0. So the first part's answer is 2 and the second part's answer is 0. I hope this was a good question, like finding out the range and all. In this like finding the range for this thing, we had to study and do some things. Okay, we had to study the graph and nature. So this was a good question. I guess now I will proceed on to the next question. So here's the next question, guys. So after many days we have finally a good comprehension type question on integration. This is a good question on very fundamental properties. You can try it out if you want. I will wait for a few seconds. Okay, so I'm starting off now. So basically this integral is given to be your I of m, and we have to evaluate this because values have been asked. Okay, so let's write the integral first. This is your I of m, which is given to be integral 0 to pi ln of 1 minus 2m cos x plus m squared dx. If we now write I of minus m, this will come out to be integral 0 to pi. Basically, the idea behind writing I of minus m is because they have given it here. That's why. So this thing is your ln of 1 plus y because minus m. So plus 2m cos x and plus m square dx. Now what I will do is, in this I of minus m, I will apply King's rule. I hope you guys know what King's rule is. It is basically your, like, what we say, integral a to b f of x dx is integral a to b f of b plus a minus x dx. That is actually called King's rule. I said the name, but if you guys don't know, you should remember the name also, okay? Because many guys are not familiar with the name. So this thing actually becomes, after applying King's rule, we can write this as 0 to pi 1 plus 2m of cos pi minus x and plus m square dx. So now if we try to evaluate this particular thing, this will become integral 0 to pi, and this is coming out to be 1 minus 2m cos x plus m square dx, which is your I of minus m. So basically our I of minus m and I of m are actually same. After applying King's rule, I of m is equal to your I of minus m, which basically gives us the answer to this part number 6, and it automatically becomes 0 because we are subtracting two equal things. So now we have to also find out some other stuff. Let's proceed with that. So what I will do is, I will add up I of m and I of minus m. Okay, that's what we generally do, right, in King's rule. That's what I am doing. So basically this will become integral 0 to pi, and the ln of this thing, okay, I forgot the ln here, I guess. There is a ln here also and here also. So if we add, basically we will be adding these two lns, and you know ln a plus ln b is nothing but ln ab. Now ln ab here is 1 plus m square plus 2m cos x in this part. Basically what I will do is, I am not, like, don't have a misconception that I am taking this I of minus m for manipulation. I applied King's rule to I of minus m basically to prove this thing. But, and also this will be required later on in this step, but I am, whenever I am adding this thing, I will be taking this particular form. And there's a reason behind that. The reason is that because we have 1 plus m square here, and 1 plus m square minus 2m cos x, and 1 plus m square plus 2m cos x. So a plus b into a minus b. Something of that sort will happen, and we will automatically have this, which is 1 minus 2m square cosine 2x plus m power 4 dx. This is what we will have. So now I guess you can observe something from here. And the observation is that this thing is nothing but your I of m squared. So your I of m plus I of minus m. Now we can write this as 2 times I of m because both of them are equal. This is equal to I of m square. So I of m square by I of m, this is equivalent to 2. So now number 5 option basically tells that we have to put m equal to 3. Okay, just a minute. Okay, so what we will do is, we will now first put m equal to 3. So we will have I9 by I3 equals to 2. And because we had I81 here, so I am putting I9, like m equal to 9 here once again. So I9, and this is your I81, this comes out to be also 2. So if we multiply these two expressions, I of 9 gets cancelled and we get our desired result. So basically our multiplying these two I of 9 getting cancelled, so I81 by I3, this comes out to be 4. This is your I81, okay. That's the final answer to this question. And the first part was pretty easy, it was 0. So yeah guys, I guess this will be the end for the Allen questions, and now I have picked out random PYQ. And what I will do is, I will not only solve, I will also try to analyze the complete question. This was a previous year JEE Advanced, not obviously from this year. if you want, like if you guys want the solutions to this year's JEE advanced questions, you can go to my channel, and there at the base, okay, they were, I guess they were the first videos I did. You will find out that I have posted the complete paper solution for JEE advanced, I guess in 2 or 3 videos, I don't properly remember. But yes, you can find out all the questions. I have done the solutions to all the questions. You can find it out there. So I will not be discussing this year's questions. I will go on to last year's questions and discuss them. For this year's questions, you can refer to those videos. Okay. Anyways, I will move on to the PYQ question right now. So here is the PYQ question, and this question is from our JEE Advanced 2021. And now calculus is one of my personally my favorite topics in maths. So I picked out this question, and this question is a bit special because the first time I solved this I couldn't solve. I still remember. Okay. So I guess you guys have, if you have done PYQs, very good. And if you haven't, and if you have also, please do this question once again. Okay. PYQs are something that you should practice repeatedly, is my opinion. Like these things are, at least before your JEE advanced, do your PYQs 2 times. Okay. I had done myself, and that is why I am telling. So please do all your PYQs. Like even if you want, this might be bit strange opinion, but if you want to, if you have time, okay, like if you crack on your January mains very efficiently, and after that boards come in, okay, so your boards go on, and maybe till March, I guess in my year it was March, I don't remember, March, it lagged till March 26th or 27th we had our computer exam. But anyways, before that you will have some sort of time, right? Generally what happens is computer exams in CBSE boards, I'm talking about CBSE boards, the computer exams are at the just at the end of everything. And like you generally have, we had before our computer exams, I guess 16 or 17 days gap. So basically people who haven't read computer all year will maybe crack everything that is present in the book. Anyways, you will have time. So if you can, okay, please all, not only JEE advanced PYQs, you can practice selected questions from JEE mains also, only for maths. Okay, I will not talk about chemistry and physics, and no use also, because chemistry and physics advanced level is much, like there is much difference, but maths in JEE mains there is not much difference with advanced, as I can observe, okay, seeing the previous trends. So if you want not all questions, you can practice selected good questions in JEE mains also. I will maybe make a video on this. There are some questions I had noticed which if they give you in JEE advanced paper, you won't be able to differentiate whether this question is a mains level question or an advanced level question, and this has happened. So while practicing, you can mark out such questions and later on practice them. It will be very beneficial. Anyways, you can try out this question if you want. I will pause for a few seconds and then we will do some critical analysis on whatever is given. Okay, I'm starting off. So basically, if we observe, we have to read the question properly. Always remember, JEE Advanced questions are like, there is some sort of trick hidden in the first part of the question itself. Okay, even in 25, when I gave the paper, there were pretty many questions which had tricks hidden in the first few lines. Okay, and many people won't see it. Even I also didn't see. I would be honest, I lost, I guess, just one question in the first paper. One integer type question I lost because of that. So please be cautious. Anyways, for real numbers alpha and beta, both of them belong to real. And we have let y alpha or comma beta be a function of x, where x belongs to all real, and let this be a solution of this differential equation. This is dy by dx plus alpha y equals x e power beta x. Now this question is something of the sort that you will, like, when you see this part, you will get pretty happy that what sort of question have they given in advance, but when you see this part, you will get a dire shock, because there's actually where things get pretty complicated. Okay, now I don't have to tell this, you guys can realize that this is a linear differential equation. And so we have to basically calculate the integrating factor and all. And they have given us a set S which contains all such y alpha and beta. And the main point is they have provided no restrictions on alpha and beta, which means that we have to take cases. Many conclusions from here. We have to take cases. You should remember, because if there is no dire restriction provided on alpha and beta. And I guess this question was in multiple correct also, which means out of ABCD, more than one can be correct if you find out all the cases of alpha plus beta or alpha comma beta. Anyways, let's slowly proceed with the question. So first, let's calculate our integrating factor, which is our e power integral alpha dx. So e power alpha x. So generally, solution to this particular question will be y e power alpha x equals integral x e power alpha plus beta into x. Now here's where things get a little bit complicated. So what we will do is, I will not go into the manipulation of this integral right now. We can easily manipulate this anyways. This is just like x e power x and you apply by parts and split it. Just a constant, you can say x e power ax. So you can easily split this using by parts, but I am not doing that right now because I am taking the cases for alpha and beta. So let's do that first. So now from here there can be a pretty obvious question that what type of cases can we take? That's a pretty obvious question. Like we can take alpha to be even, beta to be odd, alpha to be some multiple of something, beta to be some multiple of something. Now this thing can be a bit confusing, but you can see that this integral solely depends on alpha plus beta. Okay, you can see this integral solely depends on alpha plus beta. So what we will do is, whatever cases we take, we will manipulate that only on the basis of alpha plus beta. So what I am doing is I am taking a case A where I am considering that this alpha plus beta term is actually 0. Okay, this can be a case, right? Anything can be. So let's take alpha plus beta equal to 0. Let's take this as one case, and in the other case I will take all other cases to be equal and I will write alpha plus beta is not equal to 0. Okay, so now if we take alpha plus beta as 0, this equation becomes y e power alpha x is equal to integral e power 0 is 1 and x. So x square by 2 plus c. This is it. And now just a minute. We have a very important information given. I didn't write, I guess I forgot to write that at the top. Y of 1 equal to 1. Basically for finding the constant. So let's put that here. And if we put x equal to 1, y equal to 1, I guess this will become e power alpha equals half plus c. So basically our c comes out to be e power alpha minus half. So y e power alpha x becomes equal to x square by 2 plus e power alpha and minus half. And now if we multiply, like if you observe the options above carefully, I will show you one option. If you observe the options carefully, it's f of x only in the left hand side, which means we will only have y in the left hand side and nothing else. So this is unnecessary. So we can multiply e power minus alpha x on both sides. So this becomes x square by 2 e power minus alpha x plus this, I guess, becomes e power alpha minus half times of e power minus alpha x. Now this is in case of alpha, but thing is that we don't have anything given singularly in terms of alpha. So let's take something general, I guess. Let's take a hit and trial. Let's put alpha equal to 1. Let's do that and see what happens. So y equal to x square by 2 e power minus alpha plus this thing becomes e power alpha minus half and e power minus x. Okay, not alpha, I'm sorry, x. So this is it. And now I will try to match the options. If any of them is matching, I will check once. So yes, actually putting this thing was actually successful, which means our substitution is getting correct. Okay, because A option is matching with the equation we just found out, which means that our substitution was correct. So now let's do the alpha plus beta not equal to 0 substitution with a second case and see what happens. So in the second case, if we take, say we take this as case number B, where we say that alpha plus beta is not equal to 0. So now basically our equation is just as before. This is integral x e power alpha plus beta times x dx. So now we have to manipulate this using bypass, pretty obvious. So I will quickly do that. So this thing will become your, first what we will do is we'll write this as x e power alpha plus beta times x divided by alpha plus beta. Basically I took this to be your, this part to be v and this part to be u, and this is coming out to be minus 1 by alpha plus beta. It is a constant, so I kept it outside. And integral of e power alpha plus beta into x. Why? Because our x has been differentiated as 1. So now if we manipulate this a bit, this will come out to be x e power alpha plus beta times x whole divided by alpha plus beta, and this thing comes out to be your e power alpha plus beta whole x integral. Okay, so I guess minus e power alpha plus beta times x divided by alpha plus beta whole square plus c, and here we have y e power alpha x. So this is your equation. Pretty big equation, but nothing to do. So now if we have to put 1 comma 1 in this particular thing, we will have e power alpha equals to e power alpha plus beta by alpha plus beta minus e power alpha plus beta whole divided by alpha plus beta whole square plus c. So c comes out to be your e power alpha minus e power alpha plus beta whole divided by alpha plus beta plus e power alpha plus beta whole divided by your alpha plus beta whole square. This is what we have as the value of the constant. So now let's put this into our final equation and let's manipulate that a bit. So finally our equation becomes y e power alpha x equal to x e power alpha plus beta times x divided by alpha plus beta minus e power alpha plus beta times x whole divided by alpha plus beta whole square plus e power alpha minus e power alpha plus beta by alpha plus beta plus of e power alpha plus beta whole divided by alpha plus beta whole square. So you can see this is a very big expression. Anyways, this will shorten just in a while. So now what I will do is, we have y equal to here, right? So I will multiply this particular complete thing on both sides with e power minus alpha x. So this will come out to be e power beta x here also will I guess have, okay, this will be 1, here we will have e power beta x, here also e power beta x, and everywhere we will have e power beta x. So what I will do is I will take e power beta x and I will also take alpha plus beta whole square. This thing we will take common out. The reason being, inside we will be left with alpha plus beta times x and I guess minus 1 from here. And this thing will become plus of e power minus alpha x times e power x minus e power alpha plus beta by alpha plus beta plus e power of alpha plus beta whole divided by alpha plus beta whole square. This was a bit long. This question was a bit long, but now this will quickly shorten if we take our important case, which is putting out the point x equal to 1 and y equal to 1. We can put this, right? Obviously we can. So, okay, not x equal to 1, y equal to 1. I'm sorry. Not x equal to 1, y equal to 1. I said the wrong thing by chance. We will put alpha and beta as 1. Why? Basically because alpha plus beta is not equal to 0. That is the first thing. And second thing is they are like not equal to 0. So we can put 1, right? Our wish. Basically this is no logic behind. I am just getting hit and trial, and another reasoning that you would give is we had alpha equal to 1, find a solution to us in the first case, so why not take a hit and try out, right? So I will change the page and put alpha and beta as 1. So if we put alpha and beta as 1, this is actually coming out to be e power x by 2 square, so 4, and this is your 2x minus 1 plus e power minus x times e minus e square by 2 plus e square by 4. So basically y becomes equal to e power x by 4, and this is x minus half plus e power minus x times, I guess e minus this thing will be e square by 4. This is what we have. So we'll check out if any of the options is matching with this or not. So yes guys, our option number C is also matching. I guess no more cases can be made, or we can actually make cases like, I will take a hit, maybe if we put alpha equal to beta equal to say minus 1, what is happening? It is e power minus x by 4 times minus of 2x, so minus e power minus x by 4. I will check once if there is any option like this, minus e power minus x by 4. So we can actually find one option, but there is a but, because A option had x square by 2 e power minus x. So basically if you compare A and B, then B becomes wrong. Okay, I understood now. If you actually compare, like if we have got A and C, right? If you see B and D, they are actually opposite contrast, some sort of opposite contrast to them. Like if A and C are correct, B and D can't be correct. Correct, like you can easily observe and tell, right? Yeah, so question is done and our options are A and C. It was pretty tedious, like lots of calculation involved. But the question wasn't simple, I won't say simple. This is a JEE Advanced 2021 question and pretty difficult, but yes, if your fundamentals are clear, you can easily solve. And please keep your eyes open whenever solving the question, okay? So now if we try to analyze this question, like why had they asked this? And what can we derive from this to come in the near future? So basically, the main idea behind asking this was, like this is my opinion, if you guys actually see the options, right, there will be like a category of people who will try to differentiate these equations, I am sure. Like in the exam hall there, when people observe this alpha plus beta and all this, like all this ruckus coming out, there will be a category of people who will try to differentiate these equations. And while differentiating, like every person has minimum amount of IQ also. So if you see that anybody can guess that among AB1 will be correct, among CD1 will be correct. So if you differentiate one of these equations, you can actually like somewhat arrive to this, okay? Now my guess is that basically while preparing this question, the people who prepared, the teachers who prepared this question, they had made this equation, they had actually prepared the same way we did, but what they expected us from was this particular method only. But if you see this year's JEE Advanced questions, I have posted that on my channel as well. There was a question I can remember where we had to solve 3 differential equations and get them to one particular like limit. I guess it was y1, y2, yx minus 1 by e power 3x sin x, something of this sort. I don't exactly remember, but yes, something of this sort. So if you compare that to this somewhat, you will see there is a similarity. I can observe a similarity. Although those equations were not perfectly LDE, but if you differentiate these equations, like if you are really fast at differentiating, you can somewhat reach to this. Although I would never recommend you differentiating options and solving differential equations, because if you do that, you haven't learned anything, okay? That's like pretty simple conclusion. You do that when you are in an emergency case and you don't have any other options left. That's when you do. But I would never recommend you to like differentiate equations and solve. That is pretty bad thing. Anyways, I guess this has something to do. And if you guys want me, I can also bring chapter wise PYQs, because solving PYQs is something that is maybe I will take a lot of time, because as you can see, I am doing a full postmortem, a full scrutiny of each step, because what I basically am trying to guess is what they will give next year. That is our goal, right? Anyways, this was today's video guys, and I hope you liked it. And if you have any minor doubts and anything, you can always ask out to me in the comment section. And one more request, if you guys want me to prepare anything on PYQs, like separate videos on PYQs, because PYQs are extremely important. Or what I can do is I will try to bring out, like, you can also if you want me to do this, I will maybe try to post a poll about this. I can make videos on PYQs, like I solve one PYQ and after that I give you 2 or 3 questions which are perfectly related to that. I can also do that if you want. Anyways, whatever it is, if you have any ideas, please do post me in the comment section. So that's it for today's video, guys. If you like this video, please do like, share and subscribe, because that's what keeps me going. And I guess this will be the end of today. I will keep bringing such questions in the next videos too. And thanks for watching.